Welcome, guys, gals. We're going to go through polygons, our last lesson for the week. I'll be working this weekend to try to get next week set up. It will come to you in a very similar format. If you want, you can pick up any papers on Monday, and report cards should be ready later today. Polygons. Now, some trapezoids are parallelograms. Is that true or false? Trapezoids only have one parallel side, or a pair of parallel sides. Parallelograms have two. Some figures with four right angles are squares. That is true. Some are also rectangles that aren't squares. Some quadrilaterals have only one right angle. That can be true. Good job, proud of you. Learn to identify regular and not regular polygons, and define the angle measures of regular polygons. Regular means all sides are equal to one another, and all angles are equal to one another. So that does make a big difference. That allows us to find out the measures. We have polygon, regular polygon, diagonal. A polygon is a closed plane figure formed by three or more line segments. A regular polygon is a polygon in which all sides are congruent and all angles are congruent. Polygons we've dealt with our quadrilaterals, with our triangles, and it goes on to pentagons, hexagons, heptagons, octagons, nonagons, and decagons. And you could go on, but we're not going to. Now, polygons are named by the number of their sides and their angles. Their number of sides and their number of angles just happen to be the same. So, here's this picture. Hopefully you can see it pretty well. If you cannot, the same one is in your book. Be ready to pause and you can compare and look there. Triangle, 3 sides. Quadrilateral, 4. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8. Nonagon, 9. And decagon, 10. Notice, if they're regular, all sides are the same. All angles are the same. If they're not regular, they don't have to match up. Regular, all sides, all angles the same. Not regular, they don't have to match up. However, a triangle that's regular and a triangle that's not regular, both have 180 degrees. Now, that becomes important because if this one is regular and all the angles are the same, well, we divide by 3 and know that each angle is 60. Alright, that becomes important. Dividing equally means we can use division. We divide by the number of angles. So this one we take 360 divided by 4. This one would be 540 divided by 5, and so on. Tell me whether each shape is a polygon. If so, give its name and tell whether it appears to be regular or not. This has 1, 2, 3, 4, 5 sides, so hopefully you know it's the pentagon, which is now closed. Also, the angles look a little bit different, so we would say it is not a regular polygon. The shape, polygon, there are 5 sides, 5 angles, pentagon, and all sides do not appear to be the same, so it's not regular. This one, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. 8 side means octagon. Now, all angles look to be the same, so it is regular polygon. 8 sides, octagon. Oh, and 8 angles. And the sides and angles appear to be congruent. Regular. Alright, this one. It looks like all sides are the same. It looks like all angles are the same. Hopefully you remember from yesterday's lesson, this is a rhombus. And if those are 90-degree angles, it is a square. We look at that. There are 4 sides, quadrilateral. There are sides appear to be congruent, regular. All right, this one. Ooh, all angles appear to be the same, but the sides are different, so it is a polygon. That is a quadrilateral. And all sides are not equal, so it's not regular. All right. Now, you can divide any quadrilateral into 2 triangles by drawing a diagonal. Remember, we don't need to draw a lot of them. You need to draw just one diagonal for a quadrilateral. because we want all the angles to be touching the edge. If I add extra triangles, something like this, do you see how these angles here, which will be part of our 180 for some of the triangles, they're not on the edge, and therefore they mess up our calculation. So, you want to do as few lines as you can to make it all triangles. Since there are two triangles, 180 plus 180 makes the 360. Alright? That's how we can tell how many degrees are in a shape. Malcolm designed a wall hanging that was a regular 9-sided polygon called a nonagon. What is the measure of each angle? Now, if you remember Mrs. Carnahan's lesson, 9 sides, we subtract 2, that equals 7. Now, the reason we subtract 2 is because if we make a 9-sided item and we put 7 lines inside of it, that means there's going to be 7 triangles. Okay? So then we take the 180, which is the number of degrees in each triangle. Take it times 7. 0, 56. That's a 5, is 12. There's 1,260 degrees in a nonagon. Now, if there's 9 angles, they're all the same. We can use division. 1,260 degrees for the whole degrees, divided by 9, so we figure out each separate angle's degree. 1, that's a 9 and a 3. 6, oh, it goes in there 4 times, 36. Don't forget your placeholder there. Each one is 140 degrees. Let's see if we're right. 140. Alright, understand the problem. Alright, what's the important information? Make a plan. Make a pattern to look for a table. Oh, triangle. Pentagon. There's 5 sides, there's 3 triangles. Oh, sides, 3 to 1, 4 to 2, 5 to 3, 6 to 4. Every time we subtract 2. So since we have 9, we subtracted 2 and got 7 triangles. Therefore, we took the 7 times the 180, got 1,260. I know I did that. And then we take that divided by 9 and we get 140 degrees. That lesson that Mrs. Carnahan taught becomes important in a lot of ways, so you've got to try to remember these things. We look back and we're here. Now, Sarah designed a picture that was called a regular 6-sided polygon. Regular, all of the same. Called a hexagon. What is the measure of the hexagon? Now we're going to take and draw one out, just because I want to show off my wonderful drawing skills. We're going to also pretend that this is regular. Remember, start at one edge. That's one triangle. Continue at that edge. 2 triangles. 1, 2, 3, 4 triangles. That 6 sides minus the 2 equals 4. 4 triangles. 4 times 180, because each triangle has 180 degrees. 2, that's 3, that's 720 degrees. Now, hopefully you remember what to do with the 720. 720 for all of them. But if I want to know what each one of the 6 is, I probably should divide. 16. Okay, so with 16, we will go in there twice. That's 12. Oh, I copied things wrong. Please forgive my error. Should have been 720. I believe that'll make our math a lot easier. That's 2. That's 12. Placeholder. 120 degrees is each one of these angles. So when we add them all together, we get 720. Let's check it out and make sure our math is matching their math. All right. Make a plan. Remember, we look for our patterns. 3 sides means 1 triangle. 5 sides means 2. 6 sides means, 5 sides means 3. 6 sides means 4. Oh, so we take our 6 minus 2, get our 4 triangles. We do the 4 times 100, 720. For each angle, if we want it to be the same, we divide by 6. And there we go. We look back, and each angle in a hexagon is obtuse, 120 degrees. That is a reasonable answer. All right. That's everything we've got for polygons. Remember, pause and look back if you need. Give me a contact, because sometimes this can be difficult.